Here's an example. Again, I wrote all the steps out for you. Please take your time when you're doing this problem. So we want to verify that this equation is in fact equal to each other. So again, we're going to work with the left-hand side, and we're going to work with the more difficult side. So this is our left-hand side, and we want it to get to look like this when we're done, 2 secant squared of theta. So we're working with the left-hand side only. What we have here are 2 fractions, and we want to combine them together. So let's look at the 2 fractions. Are the 2 fractions denominators alike? No. So at this point, we can't combine them together until we get the denominators to be exactly alike. So you want to find the LCD, the least common denominator. So there's nothing alike, so we need to do some manipulating of these denominators. So what is the LCD? The least common denominator. So nothing's alike. We have to identify that this is 1 minus the sine of theta, and this is 1 plus the cosine of theta. I have to have both of those pieces. So what am I missing here? And what am I missing there? Okay. So what we did is we increased this first fraction. Here's my first fraction, 1 minus the sine of theta. I don't have this 1 plus the sine of theta. So I have to increase it here and there. Now, let's look at the second fraction. The second fraction has 1 plus the sine of theta. But what am I missing? I'm missing this 1 minus the sine of theta. So I have to increase it on the second fraction with the 1 minus the sine of theta in the numerator and the denominator. So now let's look at the 2 fractions. Are the 2 fractions exactly alike? Do I have a 1 minus the sine of theta? A 1 minus the sine of theta? Yep. Do I have a 1 plus the sine of theta and a 1 plus the sine of theta? Yep. I'm good to go. I can combine these 2 fractions into one fraction. So that's what it looks like. Here's my LCD. And then I have my 1 plus the sine of theta times 1. And I have my 1 times the quantity of 1 minus the sine of theta. Now I have some simplifying to do within that fraction. So first step is if I distribute this 1 through or that 1 through, it doesn't really change the expression at all. So I just have 1 plus the sine of theta, 1 minus the sine of theta. I haven't done anything with that denominator yet. If you wanted to, you could. You could FOIL that out. But we're taking this problem nice and slow. Now, I want to combine like terms. So I have a 1 plus a 1, and I have a positive sine of theta and a negative sine of theta. Now you're going to see some things cancel out. Do you see it already? And some things combine together. Well, the sine of theta and the sine of theta cancel out. So we're just left with the 2 in the numerator. All right, we're getting there. Now we're going to FOIL. FOIL, first, outside, inside, last. You could have done this earlier, but I just kind of take the problem nice and slow. 1 times 1 is 1. That's your first. Outside, 1 times the sine of theta. Inside, negative sine of theta times 1, negative sine of theta. And then last, negative sine of theta times positive sine of theta is negative sine squared of theta. So we FOILed the denominator. Do you see anything cancel out in the denominator? Yes. You should see that the sine of theta and negative sine of theta cancel out. So now we just have the 1 and the sine squared of theta in the denominator. Haven't done anything with the 2 yet for a while. Now we have a Pythagorean identity right there. The Pythagorean identity, if you remember, is sine squared of theta plus cosine squared of theta equals 1. That's what it shows on your sheet. But it doesn't look like that. So what do we have to do? We have to manipulate it. So I'm going to solve this for the cosine squared of theta. So I'm subtracting by sine squared of theta. Well, here it is. It's right there. So now I can replace it with cosine squared of theta. There's your Pythagorean identity. All right. Now what I've just done is I've just split up this fraction into 2 pieces. The 2 times 1 over the cosine squared of theta. Do you see another identity that we can use now? Right here. The reciprocal identity says this. The secant of theta equals 1 over the cosine of theta. Well, I have a square there. Doesn't make a difference. This just becomes a 2. That becomes a 2. So if here's my 1 minus the cosine squared of theta, I can replace it with secant squared of theta. So there is my final equation on the left simplified down. Now let's go back up to the top of our problem. There it is. 2 cosecant squared of theta is what we wanted. And so we've just verified that identity.